Okay, so to continue, we have three objectives. First is to describe principal roots and tells whether they are rational or irrational. Second, determines between what two integers the square root of a number is. Third, estimates the square root of a whole number to the nearest hundredth. And we're going to start with the first one. Find the principal root of square root of 49. When we say square root, it is a number that is multiplied to itself to come up with the given product or answer. Since we're talking about 49, we all know that 7 times 7 is 49. So therefore, the square root of our 49 is positive negative 7. Okay, here is how you write this when we say square root. Okay, so the answer is positive negative 7. But when we say principal square root, it means we only take the positive. So our answer on that example should be just positive 7. Okay, just the positive 7. So it's different. When we say square root, our answer will always be positive negative 7. But when I say principal square root, the answer will always be positive only. And for the next one, okay, our next question is to determine whether the principal root of square root of 17 is rational or irrational. When we say rational, it means the result of the square root should always be a whole number. But when we say irrational, we will come up with a decimal number or sometimes imaginary number. Okay. Let me show you first the top 10 perfect square number that you can use as a guide on finding the square roots. Okay, so here it is. We have 1 squared equals 1. 2 squared equals 4. Therefore, the square root of that is 1. And the square root of 2 squared is 2. Okay, because 1 squared means 1 times 1. 2 squared means 2 times 2. 3 squared means 3 times 3, which equal to 9. So when you were asked what is the square root of 9, your answer is positive negative 3. We have 4 squared equals 16. So the square root of 16 is 4. 5 squared equals 25. Therefore, the square root of 25 is 5. 6 squared is 36. So the square root of 36 is 6. Next is 7 squared is 49. The first example that we solved, the square root of 49 is 7. And 8 squared equals 64. So the square root of 64 is 8. Then we have 81. Or 9 squared equals 81. So therefore the square root of 81 is 9. And lastly, we have 10 squared equals 100. So the square root of 100 is 10. But it will not stop on that, because it can still continue up to the 11 squared, actually up to 20 squared, 21 squared, and so on and so forth. As long as, again, the square root is a number that is multiplied to itself. But you can still find the square root of that 17. But for now, the square root of 17, since the question is if it is rational or irrational, so therefore our answer is it is irrational, since it is not included in this list that I showed you. Okay, let us move to our third example. It says here, between which two consecutive integers does square root of 6 and square root of 75 lies? When we say consecutive integers, it means, for example, 1 to be followed by 2. So that's how you say consecutive. You can say 2 to be followed by 4. It's not consecutive. Okay, let us try on finding the consecutive integers that lies on the square root of 6 first. Okay, on the table that I showed you, we all know that before square root of 6 and after square root of 6, we will think of a number that is greater than 6 and less than 6. So first is the square root of 4, because 4 it has a square root. Then on the right side is the square root of 9. This is how you write it. Okay, we have here the greater than and the less than symbol. This is how you read it. Square root of 6 should be greater than but less than. Okay, so we'll write on the left side the square root of 4. Then we'll read it again after I write the complete statement. Okay, so this is how it looks, and this is how to read it. We have square root of 6 is greater than square root of 4 but less than square root of 9. This time, since the only asked question is to determine between which two consecutive integers, so we just need to find out the square root of those 4 and 9. So the square root of 4 is 2. And the square root of 9 is 3. So our answer, it is in between 2 and 3. So that will be the answer, between 2 and 3. How about the square root of 75? Again, we will think of a number that is less than 75 and greater than 75, then find its square root. Make sure that the square root of it is a consecutive integer. Okay, so from 75, we can think of 64. Later, we will get the square root of that. From 75 also, we can think of the next one, which is 81. Again, we will get the square root of that. So, the square root of 64, we all know that it is 8 on the table that I showed you a while ago. And the square root of 81 is 9. So therefore, square root of 75 is between 8 and 9. So that will be our answer. Again, make sure that your integers are consecutive. Okay, for the final example, on this final example, the question is to estimate. Okay, on the third example, we just give the two consecutive integers. But on this one, we will give the estimated square root since it is irrational or a not perfect square number. So we have here two examples, the square root of 10 and square root of 45. Let us start with the square root of 10. Okay, we all know that the square root of 10 can be in between 3 and 4. So since it is in between 3 and 4, we will think of a decimal number this time that we will multiply to itself until we reach the nearest hundred or the nearest number to our 10. Okay, so since it is between 3 and 4, I can choose, since to the nearest hundred, let us choose 3.16 to be multiplied to itself. Okay, we have 3.16 times 3.16. So we have 6 times 6 is 36. Next, 6 times 1 is 6 plus 3 is 9. Another one, 6 times 3. Okay, so for the first one, we have 1,896. So next, we have 1 times 6 equals 6. 1 times 1 equals 1. 1 times 3 equals 3. So we have 316. And for the last one, 3 times 6 equals 18. 3 times 1 equals 4. Next, 3 times 3 equals 9. Okay, after we multiply all of it, then we have to add. So bring down 6. 9 plus 6 equals 15. Carry 1. So you have 1 plus 8 is 9 plus 1 is 10 plus 8 is 18. Again, carry 1. Then we have 1 plus 1 is 2 plus 3 is 5 plus 4 is 9. Then bring down the 9. For the decimal places, you need to count how many decimal places you have when you multiply 3.16 by itself. So therefore, you have 1, 2, 3, and 4. So on your answer, you should have 4 decimal places. So we will have our final answer will be 9.9856. Since it is the nearest to our 10, so our square root of 10 will be 3.16. That's the answer, 3.16. And for the last example, our square root of 45. Okay, our square root of 45 can be in between 6 and 7. So we will choose a decimal number again that to be multiplied by itself. Okay, for this time, I will choose a little bit higher. So I choose 6.7. It's the same as your 6.70. So we have 6.7 times 6.7. Okay, so 7 times 7 is 49. 7 times 6 is 42. Plus 4 is 46. Okay, so we have 469. And for the last to be multiplied, 6 times 7 is 42. Six times 6 is 36 plus 4 is 40. Again, after multiplying, we need to add. So bring down our 9. 6 plus 2 is 8. 4 plus 0 is 4. Bring down the 4. So we have 4,489. But again, since it's a decimal, count the decimal places of 6.7 when you multiplied it to itself. So we have 2 decimal places. So you will have 44.89. Since it is near now to our 45, we can conclude that the square root that is nearest hundredth of 45 is 6.7. So our answer is 6.7. So that's our example for the last one. Okay, next. After having those examples, here are some questions. How do you find the principal square root? Next, when can we say that the principal root is rational or irrational? Next, how to find the consecutive integers that lies on the given square root? And lastly, how to estimate a square root to the nearest hundredth? So that is not yet your quiz, just a guide question on how to find those examples. Next, again, when I say square root of a number, it is when you multiplied it to itself that will give you the original number. If the square root of a number is non-terminating, non-repeating decimal, again take note, it should be decimal. we say that it is an irrational number, because if it is a whole number, therefore it is rational. Again, every positive number has two square roots, and that is one is positive and the other is negative. But when we say principal square root, it is the positive square root only of the given number, or radicand. The number inside the square root symbol is what we call radicand. And finally, after hearing those example and explanation, here is your quiz for afternoon session. Okay, learning task 2, again, letter A. It can be found on your module, page 27. Tell whether each of the following is rational or irrational. If it is rational, give the principal root. Only if it is rational. If not, then don't give the principal root. Next. Okay. Task 2, letter B, on the module pa rin. Between which two consecutive integers does the square root lie? This is on our third example. You just give the two consecutive integers that lie on the given. Next, task 2C. Again, it is on the module, page 27. Estimate the square root to the nearest 100. This is on the last example that I showed you. Again, we all know that after every lesson I give you, you need to write a reflection. Again, you can choose a reflective mode of your documentation, either video blog, narrative post, photo journal, or to any preferred reflective mode of yours. Just state the 3 statements. I learned that, I realized that, I will do. And again, we can finally say, madaling-madali ang math, as simple as that. Again, I'm your teacher, Maria Eliza Nunez, now signing off.